Today's topic of discussion is coupling. In our last video lecture, cohesion was discussed in a very detail. Cohesion and its 7 types were discussed in a quite detail. Cohesion was about the relative strength of module. Cohesion exists among the different elements belong to a particular one module, while coupling is the measure of the interconnection among two or more than two modules. It was also discussed that to achieve a quality product, we will strive for the lowest coupling as much as possible, while there is no restriction on the cohesion. If the cohesion ratio is high and the coupling ratio or rate is low, that is a good. Types of coupling. So these are the 5 coupling types which will be discussed in this video lecture. The first, which is the most desirable and most used coupling type, is the data coupling, where the two modules are in data coupled if they communicate by passing data. Means one module pass data to another module. Both modules are independent from one another, such that one module will not control other module but only pass data. This means, and this is the definition of module, that every module will exhibit a unique property and characteristics. So if there are two modules, this means both are different in functionalities. So in data coupling, one module will require the data of another module, so data will be passed. Example include when the product detail, product information such as product ID, product name, sale price, etc. are passed from product module, stock module to a sale order module. Because sale order depend on the product stock or warehouse module, product warehouse module. So passing the data is mandatory. Another example is when student ID is passed from student into the module, to attendance module and exam module. Student ID is passed from the student info module, student information module, to student attendance module and exam module. Because in exam module we require the student ID or the student information. Similarly, in attendance we also need the student information. So the student information are passed from the student info module to the attendance and exam module. And another example is employee data is passed from the employee module to the payroll module. What is payroll? Where the pay of the all employees are finalized. So the employee data that is stored in the employee module will be processed and will be put from one module to another module. So that is the concept of data coupling. For data coupling, we need a strong programming statements which will put data from one module or table of one module to another. Stem coupling. In stem coupling, two modules are coupled such that if a data structure is passed as a parameter, but a call module operate on some but not all of the components of data structure. This means the whole data structure will be passed from one module to another, but the second module to which the data is passed will not operate on the whole data but will operate on some of the part of it. For example, passing a whole record of student to a function that needs only field of it, such as address. So that is a particular limit selection of fields from the data structure. So that is called a stem coupling. Control coupling, as the name suggests, control means one module will control another module. So when one module comes under the control of another module, that is called a control coupling. Or one component control execution of another component. For example, in fire alarming system, alarming devices which alarms are controlled by the heat sensors. So alarm sensors receive a flag signal from the heat sensors. Similarly, we can take many examples like printer under control of computer PC, robotics systems, all the sensors, all the output device wait for the sensors, etc. We can also take example of hardware such as processor control the input output device such as RAM, keyboard, etc. So these are also the example of control coupling. But in software context, we can take example of the digital systems, robotics, etc. Common coupling takes place when a number of modules access the data in a global data era. In a figure below, module C, G, and K exhibit common coupling. So we have different systems, different components belong to different systems that are separated in a global area, and whenever they need it, they can combine, such as in case of service-oriented systems. This is the common coupling. So they share the common data. Content coupling, which is the least desirable. Why it is the least desirable? Because in content coupling, one module modify data of another module. One module goes and start modifying the data of another module. For example, sale remaining amount is passed from sale module to customer account module. Customer account module is responsible for saving the debit and credit information of the customer. So when the customer puts some order and there remains some balance, the sale balance, so where it will goes to the customer debit account. So this means the customer account module is modified, the data is modified. By which module? The sale module. Similarly, we can take example of any systems. It's like the student registration. If a student is going to register himself and he don't give whole fees, so the remaining fees will be entered into the student account. Design heuristic for effective modularity. Evaluate the first iteration to reduce coupling and improve cohesion. So first try to reduce the coupling as much as possible and improve the cohesion. Minimize structure with the high fan out. Why fan out? Fan out means that one modules control other modules. So we will try to control the fan out such that the controlling ability of one module will reduce. If it reduced, definitely the coupling will be reduced. Because the system with more coupling is difficult to control, difficult to manage, difficult to test, difficult to integrate, and difficult to reuse.